Uranus is a fascinating planet. Unlike any other planet in our solar system, it spins on its side. Imagine a top spinning sideways on a table. That's Uranus for you. It's like the planet took a tumble and never straightened up. Uranus is a gas giant, much bigger than Earth. It has faint rings and many moons, but its sideways spin makes it truly stand out. Scientists have long wondered how Uranus ended up in this unusual position. Every planet in our solar system spins on an axis, an imaginary line through its center. This axis is crucial for the planet's rotation, which in turn affects various aspects of the planet's environment and climate. The rotation of a planet on its axis is what gives us the concept of day and night. As the planet spins, different parts of its surface are exposed to the sun's light, creating the cycle of daylight and darkness that we experience. The angle of this axis, compared to its orbit around the sun, is called axial tilt. Axial tilt is a significant factor in determining the climate and weather patterns of a planet. It influences the intensity and distribution of sunlight received by the planet's surface. This tilt can vary greatly among the planets in our solar system, leading to a wide range of environmental conditions. Earth has a tilt of about 23.5 degrees. This specific tilt is responsible for the seasonal changes we experience throughout the year. As Earth orbits the Sun, different parts of the planet receive varying amounts of sunlight, leading to the progression of seasons. Without this tilt, we wouldn't have the distinct seasons that play a crucial role in the natural cycles of life on our planet. This tilt is what gives us our seasons. During different times of the year, the northern and southern hemispheres are tilted towards or away from the sun, resulting in the changing seasons. For example, when the northern hemisphere is tilted towards the sun, it experiences summer, while the southern hemisphere experiences winter. This cyclical pattern is essential for the growth of plants, the behavior of animals, and the overall balance of ecosystems. Uranus, however, has an extreme tilt of about 98 degrees. This means that Uranus is almost lying on its side as it orbits the sun. Such an extreme tilt results in unique and unusual seasonal patterns that are vastly different from those on Earth. The planet's poles experience prolonged periods of darkness and light, leading to extreme variations in temperature and weather conditions. This means it's practically lying on its side as it orbits the sun. The extreme axial tilt of Uranus causes one of its poles to be in constant sunlight for about 42 Earth years, followed by 42 years of darkness. This creates a very different environment compared to other planets in our solar system. The unique tilt also affects the planet's magnetic field and atmospheric dynamics, leading to fascinating and complex weather patterns. This unusual tilt has a dramatic impact on the planet's seasons and day-night cycles. The extreme axial tilt of Uranus results in long, harsh winters and summers, with each season lasting for decades. The planet's atmosphere undergoes significant changes during these extended periods, with strong winds and storms being a common occurrence. Understanding the axial tilt and its effects on planets like Uranus helps scientists gain insights into the diverse and dynamic nature of our solar system. Imagine a planet where one pole points almost directly at the sun for a quarter of its year. That's what it's like on Uranus. This extreme tilt means one hemisphere experiences constant sunlight for about 42 Earth years, while the other is shrouded in darkness. This dramatic tilt doesn't just affect sunlight, it also influences the planet's weather patterns and the behavior of its atmosphere. Scientists are still trying to understand the full implications of Uranus's extreme axial tilt. So, how did Uranus end up on its side? The most widely accepted theory is a giant collision early in the solar system's history. Scientists believe that a large object, perhaps twice the size of Earth, slammed into Uranus billions of years ago. This impact would have been powerful enough to knock the planet off its axis, tilting it to its current extreme angle. The debris from this impact may have even formed Uranus's rings and some of its moons. While the collision theory is the leading explanation, it's not the only one. Some scientists propose that Uranus's tilt might be due to the gravitational influence of its giant neighbors, Jupiter and Saturn. Another theory suggests that Uranus might have had a smaller companion planet that interacted with its gravitational field, slowly tilting it over millions of years. However, more research is needed to confirm or refute these alternative theories. Uranus, the seventh planet from the Sun, is a fascinating world with unique characteristics that set it apart from the other planets in our solar system. A year on Uranus lasts about 84 Earth years. This means that if you were born on Uranus, you would have to wait 84 Earth years to celebrate your first birthday. Imagine the patience required for that. Due to its extreme tilt of about 98 degrees, Uranus experiences the most extreme seasons in our solar system. Unlike Earth, which has a relatively moderate axial tilt of 23.5 degrees, Uranus's tilt causes it to essentially roll around the sun on its side. Imagine a summer that lasts for 21 Earth years. During this time, one hemisphere of Uranus is bathed in continuous sunlight, creating a prolonged period of daylight that seems almost endless, followed by an equally long winter. For the next 21 Earth years, the same hemisphere is plunged into darkness, experiencing a night that stretches on for decades. During its summer, one pole of Uranus faces the sun directly, receiving continuous sunlight and warmth, albeit not as warm as we might think due to Uranus's great distance from the sun, while the other is plunged into darkness. This creates a stark contrast between the two poles, with one basking in light and the other shrouded in shadow. As Uranus continues its orbit, the seasons change gradually, transitioning from the long summer to the long winter. This gradual change is a slow dance that takes decades to complete, with each pole experiencing a long period of sunlight followed by an equally long period of darkness. This unique seasonal pattern is a result of Uranus's extreme axial tilt, making it one of the most intriguing planets in our solar system. The interplay of light and darkness on Uranus is a reminder of the diverse and dynamic nature of our cosmic neighborhood. The extreme seasons on Uranus offer a glimpse into the complexity and variety of planetary climates, showcasing the wonders of our solar system. A day on Uranus is much shorter than its year, lasting only about 17 Earth hours. This means that the planet completes a full rotation on its axis in less than a single Earth day. In contrast, Uranus takes about 84 Earth years to complete one orbit around the Sun. This stark difference between the length of a day and a year on Uranus is one of the many fascinating aspects of this distant, icy giant. However, the planet's extreme tilt creates some unusual lighting conditions. Uranus is tilted at an angle of about 98 degrees, which means it essentially orbits the Sun on its side. This extreme axial tilt results in one of the poles being pointed almost directly at the Sun for a portion of its orbit, leading to prolonged periods of daylight and darkness at the poles. Instead of a clear division between day and night, Uranus experiences long periods of twilight and dusk. These extended periods of dim light occur because of the planet's unique axial tilt and its distance from the Sun. During these times, the Sun hovers just below the horizon, casting a faint glow that can last for hours or even days, depending on the location on the planet. This creates a surreal and otherworldly environment where the sky is never fully dark or fully light. Even at its equator, where the Sun would appear highest in the sky, the sunlight would be slanted and weak, similar to what we experience on Earth during twilight. The Sun's rays have to travel through a thicker layer of Uranus's atmosphere, scattering the light and reducing its intensity. This results in a perpetual twilight-like condition, even at midday. The weak sunlight at the equator contrasts sharply with the intense direct sunlight experienced at the poles during their long summer days. This creates a unique environment that influences the planet's atmospheric dynamics and weather patterns. The extended periods of twilight and dusk, combined with the weak sunlight, affect the temperature and pressure gradients in Uranus's atmosphere. This, in turn, drives complex weather patterns, including strong winds and massive storms. The planet's atmosphere is composed mainly of hydrogen and helium, with traces of methane, which gives Uranus its characteristic blue-green color. The interplay of these elements under the unique lighting conditions creates a dynamic and ever-changing atmospheric landscape. Uranus is a fascinating and mysterious world. Its extreme tilt, unusual seasons, and strange day-night cycles continue to intrigue scientists. Further study of this ice giant can provide valuable insights into the formation and evolution of our solar system. By sending spacecraft to Uranus, we can learn more about its composition, atmosphere, and magnetosphere. These missions can help us piece together the story of Uranus's tumultuous past and its place in the grand scheme of our cosmic neighborhood. As we explore the universe beyond our planet, we gain a deeper appreciation for the diversity and wonder of celestial objects. Uranus, the sideways planet, serves as a reminder that our solar system is a dynamic and ever-evolving place. By studying distant worlds like Uranus, we not only expand our knowledge of the cosmos, but also gain a better understanding of our own planet and its place in the grand cosmic ballet.